Uh, my name is Forad Stolz. I'm CTO at Photoneo, and I will be talking about new developments that we did in our products that are basically circulating about these use cases. It's like when the light doesn't behave with the objects and when the signal perspective is not enough for handling. But before we start, I would like to introduce our company briefly. Photoneo is a provider of 3D sensors, like hardware modules for beam picking and robotic applications. Additionally to our 3D sensors, we are also producing software that is used for robotic intelligence, beam picking, but not only beam picking solutions, where we apparently are using also AI principles. We have about 8,000 solutions worldwide. We operate through distributors and partners, and we have about 310 employees and more. The number is rising, and we have apparently worldwide operations. We are leader in vision-guided automation, vision-guided robotics. Here are a couple of our partners and a couple of little videos just to give you a flavor of what we are doing. We are providing in all these installations and many similar installations robotic vision, so we call it robotic eyes. And then the software that we are developing is robotic intelligence. Our portfolio consists of these three pillars: 3D sensors, beam picking software where AI is taking place, and also digital twinning software. It may look standing out a little bit, but I will show later like how does it nicely fit together. Our camera, MotionCam 3D, some of you are familiar. Some of the companies here in this hall are providing here. Rauscher has even demonstrator with our camera. Is probably the most advanced 3D camera that you find on the market for area scanning, 3D area scanning. What's so important about it or so different? It's because it is located in a gap of current 3D sensors, which means that it can combine highly demanding or serve highly demanding applications by providing high quality point clouds, but at the same time it's not really affected by motion in the scene. So if there is any motion in the background or in the foreground, or if the object itself is moving, it doesn't have to, but if it is, then MotionCam 3D can still provide very good data. And it is here an example how such data from MotionCam that's on the right side may look like. It's a snapshot system. The scene that you have there is not an industrial scene, but it should illustrate that even if the scene is moving and it comprises many different material types and object types, it is still, MotionCam is still capable of providing very good high quality point cloud compared to other two competing technologies that we pick. There are other technologies, 3D technologies, but just for the comparison, time of flight that is typically applied when you need very quickly undistorted data, for example, for some logistic applications or robotic handling. You get the data quick, but typically it's very noisy, and also resolution is still not the greatest. While structured light approach is great if you have a stationary scene, if the objects are not moving, but it takes time to capture that, and if the objects are moving actually during that capture time, structured light approach is suffering from severe artifacts. So if your application, but I mean, MotionCam is very good that you don't need to think anymore about, the type of applications you are dealing with. You can just take it as like now in every pocket there is a camera. You don't need to think really about, is it dark, is it bright? You just press a button and you get a nice point cloud. With MotionCam, you are there. It's a really significant leap in the 3D development. And all this is thanks to our proprietary CMOS sensor that our company has invented and developed, which is implementing something that is very different from what you see around here. Here at the Vision Show, there is like lots and lots of different cameras. All of them are taking images, either using global shutter or using rolling shutter approaches, but our MotionCam 3D and Compass sensor is implementing something that is called mosaic shutter. Why mosaic shutter? It is because pixels on our sensor are organized in a mosaic, similar to Bayer pattern, but those groups of pixels can implement different temporal sequences, temporal patterns. So we can very flexibly program those groups of patterns. It's just an illustration, which are then used to capture multiple structured light patterns in a snapshot. Here on the left side, you see a dynamic process. I was dropping a ping pong ball on a table and capturing this process with a standard structured light system that is capturing frame after frame after frame. And obviously, when the ball is falling during that process, you get, patterns projected in different time phases. While with MotionCam and Compass, this is done in a snapshot, and all the patterns are consistent, and the good 3D data can be then recovered from that. Here, an illustration how a point cloud may look like if you take this process and you drop the ball, you take a standard sequential structured light camera, you get a distorted point cloud. So at most, you might be able to remove those artifacts. But actually, with MotionCam, you have a very crisp, very good quality 3D point cloud, even if the object was moving during that process. Because actually, it wasn't moving because we took it in a snapshot. Here, very brief and quick illustration, like what's the trick? Maybe some of you are asking, like, so what's the magic? Is like our devices are stereo systems. We have a projector and a camera unit. Here in this illustration, we see how a standard structured light system would work. So there is a projector on the left-hand side that is modulating the light during the sweep. And a global shutter camera is looking at the scene, and when the frame is finished, you get a nice stripy pattern projected onto the scene, captured. But obviously, you cannot parallelize this. You cannot take multiple frames together at the same time. So what can be done differently? With a parallel structured light and mosaic shutter, we are essentially exchanging the role of the camera and the projector. So the projector is no longer modulated. Projector is just basically sweeping with a laser line from left to right. And the camera, during the exposure window, is basically closing and opening the eye. And this can produce a pattern, the same pattern as with a standard structured light approach. But this can also be parallelized. So if you have a sensor that can actually combine multiple of those patterns together in different pixel groups, you can capture multiple patterns at the same time in a single sweep. That means with our proprietary sensor, we can capture in a snapshot nice 3D point clouds, which is great. That is really cool. Here, an example, again, about the data outputs of our MotionCam. It also comprises a processing board, NVIDIA Jetson. Everything is processed directly on the camera, so the camera is sending out already a processed data, be it a depth map, be it a texture, or a 3D point cloud, or surface normals that are directly computed on the camera, but there can be also other outputs. What is important, we are probably the only 3D company that is currently supporting GigaVision protocol, fully integrated with standard softwares. So that means you are getting this basically on a golden platter, out of the sensor, without very short latency and without any need of post-processing. But this is just a sensor. This is just 3D data. But when it comes to the actual real applications, this is what we are currently, maybe over the last 2 years, facing with our customers in logistics applications. Imagine you have a warehouse. There you have, I don't know how many thousands of SKUs. Many of them are pickable. Many of them are not pick, or used to be non-pickable. And now, like, what can be done differently? Typically, light doesn't behave very well on these objects. But we managed in last year, in one of the latest releases, we have introduced new coding strategies that is then allowing us to scan even transparent and translucent objects very nicely. I'm not saying that we can really scan a crystal, glass or something like that, but many SKUs from warehouses we can scan. Now they are pickable. Now we can really handle them, localize them, and pick them with our robots. Here this slide should give you again kind of a flavor of what's going on, how this is actually happening. Thanks to the modularity and flexibility of our sensor, we have introduced new coding strategies that is basically going from this type of dense codes that are not really making it possible to distinguish different layers of the transparent object to a code that we call sparse. This is just an illustration. It's not the actual code that we are using, but it should illustrate like what's happening over there. So all of a sudden, with a sparse code, one can see, the background layer, foreground layer, mid layer, and actually, with the help of good algorithm, one could go into something like tomography, even that you would be able to build up not only the outer surface, but also inner surfaces and so on. We have introduced these novel codes, and these are just few examples of what's possible, what was possible before, and what's now. With the new coding strategies. With the help of these strategies, we are also able very efficiently suppress something that we called interreflections. Imagine you have these L-shaped parts that are essentially reflecting on each other. You are illuminating one local, patch, and this one reflects to the other one. Codes are getting mixed. With the help of new coding strategies, we can suppress interreflections very efficiently, which makes many objects pickable. Also with dark and glossy materials, we pushed, thanks to these new coding strategies, the scannability. Imagine you have an automotive part that is really dark and glossy, that is essentially acting as a black mirror. You don't get typically in huge areas any response or very weak response. Here with the new coding, we can optimize processing settings. We can capture very nicely almost the entire object. And one of the also latest developments is a new ambient light suppression that is thanks to, again, the flexibility of our platform and our way we control the sensors. We can scan in the ambient light up to 100,000 lux with a very good, recovery of the surface. If you are interested in this technology, come over to the other hall, to our booth. And now, very briefly about when the single perspective doesn't suffice, right? We have our digital twinning software called instant meshing. It supports all these scenarios like custom manual marker board or rotary table or robotic capture of the multi-view with the help of motion cam. You do not need to really stop. You can really just go around and scan. And also big gantry systems. With this, you can nicely build, 3D models of small parts, but also huge objects like cars, for example. But what is it good for? Lately, we have integrated this into our beam picking studio software. And now you can very easily utilize the power of robot, camera, and hand-eye, but not only hand-eye, also static multi-view that allows you to pick very successfully also parts like these little L-shaped thin metal objects that, if you are not lucky, you are looking from the perspective of the edge of the object, and then you basically see nothing. You cannot localize it. But with the help of multi-view, thanks to motion cam, you can do it really quickly, actually in a time of single scan with other systems. We can, in a real time, merge those multiple viewpoints, get a point cloud like that one, and we can localize these parts very efficiently. Again, if you are interested, you are most welcome in our booth. So, conclusions. if the light doesn't behave, we have introduced our new coding strategies that are allowing us to pick maybe not 100% of objects in a warehouse, but maybe 90, 95, 85, which is really big leap compared to the previous. And if a single perspective is not enough for our beam picking solution, we have introduced now a very nice extension that can merge multiple viewpoints, again allowing us to pick many, many objects. If you are interested, you are most welcome to come over to our booth. Thank you very much.